Question number 7 is an AO3 question, and this question is from the energy transfer in a system. The student need to analyze the figure number 9 and give the explanation of the question. Sample 1, figure number 9 shows a sketch graph how the maximum tendon length during a jump changes with the speed of the kangaroo. You can see the figure number 9, the speed of the kangaroo is along x-axis, which is an independent variable, whereas the maximum tendon length is along y-axis, so it is a dependent variable. So dependent variable is actually the length of the tendon. It depends on the speed of the kangaroo. If you look into the graph is a straight line which shows that as the speed is increasing, the length is increasing. Question is, explain why a kangaroo can jump higher as its speed increases. As the speed is increasing, the length of the tendon is increasing, and we can see that the graph is going up. As the tendon is stretching, so it means there is more elastic energy. And that elastic energy give the kangaroo high jump in the air. It means there is more gravitational potential energy of the kangaroo. Let's see the model answer. As the speed of the kangaroo increases, the length of the tendon increases like the spring. The stretch in the tendons produces elastic potential energy of the tendon. The elastic potential energy of the tendons is transferred into the gravitational potential energy of the kangaroo. Therefore, the kangaroo is able to jump higher in the air. 7.2 is an A2 question, and it is also from the change in energy. A kangaroo has maximum gravitational potential energy during one jump is 770 joules. When the kangaroo lands on the ground, 14% of the maximum gravitational potential energy is transferred to elastic potential energy in one tendon. The tendon has an unstretched length of 35 centimeters. When the kangaroo lands on the ground, the tendon stretches to a length of 42 centimeters. Calculate the spring constant of the tendon. So we need to find the spring constant, that is K. Students try to use a different formula to find the value of K. We have two different formulas. F is equal to K into extension, a change in length, or E is equal to 0.5 K E squared. From these two formulae, we are going to use this formula. The reason is the energy is given. If the student want to use this formula, they must be careful that there is no force is given in the question. So we need to find the value of E first. It is mentioned there that the elastic potential energy of the tendon is 14% of the gravitational potential energy. Let's see the model answer. It is given there elastic potential energy is equal to 14% of gravitational potential energy. So 14% mean 14 over 100 of mean times 770, that is gravitational potential energy. By using the calculator, the answer is 107.8 joules. The unstretched length of the tendons is also given. The tendon length is 35 centimeter and the stretched length of the tendon is 42 centimeter. The change in length is 42 minus 35, that is equal to 7 centimeter, and we need to convert into meters. Therefore, we are dividing 7 over 100, that is equal to 0.07 meter. Because 1 meter is equal to 100 centimeter. So we have the extension here, that is 0.07 meter. We need to find the spring constant K. We are going to use the formula of elastic potential energy. instead of using the force is equal to Ke. So we are using here elastic potential energy that is equal to 0.5 Ke square. 107.8 is the elastic potential energy. 0.5 means half. Value of K needs to be found, and the value of E is already calculated, that is 0.07. We will find here 107.8 is equal to 0.00245 K, and our final answer is 44,000 Newton per meter.